Hello, let's continue our Sudoku adventure with difference dots by Randall. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have white dots in the grid with numbers in them. Digits separated by a white dot have a difference of exactly that number in the dot. Doesn't matter which side is the bigger side, but if you subtract the big number from the small number, you need to get that difference. Let's use this 2 as an example. If I do a 4 here, I could do a 2 here because 4 minus 2 is 2, or I could do a 6 here because 6 minus 4 is 2. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, I think the place to start is the difference of 5. The only way to do that is a 1-6 pair. Oops, 1-6 pair. The extreme digits. Now 4 away from 1 would be 5, and 4 away from 6 would be 2. So we're basically thinking about the chain that would happen here. We're either going to go 6, 1, 5, or we're going to go 1, 6, 2. Now if we continue that train, 2 minus 3, 2 plus 3 is 5, and 5 minus 3 is 2. So we end up with a 2-5 pair here. Okay, and so now how do these work then? Okay, well, let's do this pair here, and I think that'll help. So other than 1, 6, and 2, 5, we need 3 and 4, and we know the order even. So I'm going to need a 4 and a 3 over here. If the 4 was here, we could go up. We could not go up to 5, so we'd have to go down to 3, but then we'd have to go down to 1 because we couldn't go up to 5. So it'd be 4, 3, 1. If the 4 was here, then to the right, we'd have to be another even number. So we'd have to be the 6. And then to the left, we'd have to be the 3 because the 3 needs to be used. So I guess if the 4 is on this 1 difference, we end up with a 3 on it. That makes sense because we couldn't end up with a 5 on it. Okay. If the 4 ends up here, then we have to put a 6 here, and then this would have to be the 3 because the 3 needs to go over here, and that doesn't work. So this is a 3-4 pair, and this is a 1-6 pair. I don't know if there's an easier way other than case checking to find that. That's how I did it. Okay, what else did we learn? We learned there's 2 3s looking down at this box, so 3's in one of these two. This might be helpful, the 4, 3, 2, 1 here. So difference of 4. Wonder if I can avoid the case check again. Maybe this difference of 3 is useful because we know a lot about these cells actually. So this can't be a 1 or a 6. So if this was a 2, we'd have to add 3 to get 5. This can't be a 3. If this was a 4, we'd have to subtract 3 to get 1. And if it was a 5, we'd have to subtract 3 to get 2. Interesting. I'm not sure that helped a whole lot. Does it help that there's a 3 down here somewhere? If it's on here, it's got to go with a 6. So we'd have a 3-6 pair here, and that doesn't work. We can't put a 6 here. That's really interesting. So we know there's a 6 over here, right? Or by roping, if there was a 6 down here, there'd have to be 6 up here. So where's the 3 go? 3 can only go a 6 on a difference of 3, because we can't put a 0. So the 3 goes there. Did that help? And these are the same 2 digits that are a difference of 3. So 1, 2, 4, 5. I'm not even sure I want to pencil that right now. Surely there's something else I can do. Okay, difference of 4, difference of 3, maybe difference of, well, we know the difference of 3 options here. It's feeling like this difference of 2 needs to be this difference of 2, but I'm not sure if I can prove that. It's not 1, 3. It could be 2, 4. Oh, right. So these can't be odd. Because if we have 2 consecutive odd digits, right? The difference of 2 is it's 2 odd digits. It's either going to be 1, 3 or 3, 5. Both use the 3. So these are even. These are from 2, 4, 6, and they definitely have a 4 in them. Which means this is not a 4, which means this is not a 1. So this is actually a 2-5 pair. This is a 2-5 pair, so that can't have the 2. That's a 4-6 pair. This is indeed 1. Okay. Now, I don't think, yeah, the 1 can't go down here because we can't put odds on here, so the 1 is there. Ah, we got that. This is a 6. That resolves all of this. We're going 6, 1, 5, 2. 6 then goes with 4 and 3. That's 6 and 4. 2, 5. These are the 4, 6 pair. We know the order. Very nice. These are 1, 2, 5. Okay. So if we look at the pair, let's just fill all these pairs. Well, these pairs at least. We need 2, 3 here. We need 1, 4 here. And we need 5, 6 here. Well, the only way this works is 6, 4. The only way we get a difference of 2 is 6, 4. And then 4 with a difference of 1, that's a 3. Another D2, nice. These are 3, 4, 6, so we know what those are. And then these are 1, 2, 5. So difference of 4, this has to be 1, 5. That leaves the 2 here. That makes that a 5 and a 1. 2 and 5, 2, 1, 5, and we're done. Nice, and the time was 5:25, which felt appropriate for how I ended. But anyway, cool, nice puzzle, Randall. There was probably an easier way than case checking, but I guess the way I got through it worked pretty well. Let me know how you did on this one, and of course, if you enjoyed this content, then why not leave a like, subscribe, and a kind comment below.